So good day everyone, I am Joshua Acusta and welcome to my tutorial on how to make a light sensitive LED tree. So in this project, we are going to use the LDR or the light dependent resistor as our sensor for light. So first, we have to identify the four conditions for our LED operation. When the LDR has maximum illumination, all LEDs will turn off. Second, when the LDR is completely covered, all LEDs should be on. Next, when the LDR is slowly covered, more LED will turn on. This means that as the environment gets darker, more LEDs will turn on. And lastly, for the opposite, when the LDR is slowly eliminated, more LEDs will be turned off. So here is the circuit that we are going to use as the sensor. So we have the 5-volt source that will be coming from the Arduino, and we will connect it in series with the LDR or the light dependent resistor and with the load resistor, which is 5 kilo ohms in resistance, and we will connect it to the ground, which is also coming from the Arduino. So what we are going to do here is to connect the analog input of the Arduino. So we have 6 analog inputs. We'll connect it here in the node between the LDR and the load resistor of 5 kilo ohms. So what the analog input does is measure the nodal voltage with respect to the ground. So it means it will measure the voltage from here connecting to the ground. This is how we will configure the circuit in our breadboard. So here we have the 5 volts source, which will be connected to the LDR, and then we will be connected to the resistor and to the ground. And one of the analog inputs will be connected in between the LDR and the resistor. So first, we are going to declare a variable to store the measured value of the analog input. So let us call that variable. Also, first we will declare it as an integer and we will call that variable as, for example, sensor value. And don't forget to put semicolon here. So we just declared the variable and we did not initialize its value. So next is for the setup. What we want here is to display the LDR value measured by the analog input of our Arduino to the serial monitor here. So what we want to do first is to connect the Arduino to our serial monitor. So what we will write here is serial.begin 9600. So this 9600 here is the bit rate of our Arduino here. That is all for our initialization. So first, what we will do here is to measure the value of the light intensity. First, we will write the variable sensor value and store the value measured into it. So we will write analog read. The analog read gives the measured value in our analog input-output pin. So for the parameter here, we will just write the pin that we are going to use as the analog input. So we will write A0. So that is the analog input that we are going to use. After we have obtained the measured value, we will show it in our serial monitor. So what we will write here is serial dot print for every line or ln. So what we will print here is the sensor value. We will have to put a delay here. And the measured time inside is in milliseconds. So for example, we will want the delay to be 200 milliseconds. That should be enough. We will first compile and verify whether our code here is correct. Okay, so let us just save this. And it's still verifying. So this code here is correct. And now we can try to upload this code here in our Arduino and set up the circuit in our breadboard. So now that we have connected the Arduino to our breadboard, so we will upload the code here. And we are done uploading. We are going to see what is the initial value of voltage here. So we can see that in our serial monitor here. So as you can see here, it prints the values for the next lines. Our initial value here is 60. It is not covered, or it is also not enlightened. Next, when we cover it, okay, let me try to cover this. Okay, and when I cover it more, so its value decreases. And it actually reaches a value of 0. So that is when our LDR is fully covered. And when our LDR is illuminated with this flashlight here, so let me turn on the flashlight. And okay, as the light approaches the LDR, as you can see here in our serial monitor, the value slowly increases. And it suddenly increased as our flashlight here is focused exactly on our LDR. So our maximum value here is about, okay, so it is always greater than 620. So these measured values, this will be used for our coding in the Arduino. And done compiling. So it is ready to be uploaded here in our Arduino. we are ready to upload our program in the Arduino. So let us connect the Arduino to our PC. Okay, so this is a bit hard because the cord is too short. Okay, so it is now connected to our PC. And let me move my camera a bit. There. And here is our LDR. Okay, so as you can see here, it might be covered here in the camera, but it is not covered in by the wires here. Okay, so uh, our expectation here is that the normal condition for our sensor value here is 60. So normally in the environment, 5 LEDs will turn on. So let's try this. We'll upload. Okay, so as you can see here, okay, only 4 have lit up. So let us check the values. And for our values here, okay, we have, okay, it is actually greater than 60. Okay, yes, it is greater than 60. So it means that our average here of 60, okay, so since we have set it to less than 60, then actually it should light up after it is less than 60. Okay, so let me try to cover our LDR here. Okay, is it? I covered the LEDR. Okay, so as you can see, okay, and if we completely cover it, okay, actually it is still, the last LED is still not lighting up. So we will need something to cover it completely. Okay, I've got something. Okay, and let me try this. Okay, and all of the LEDs lit up, as you can see here in our recording. And if we try to illuminate it with a flashlight, so slowly let this flashlight approach the LDR. Okay, so lastly, okay, there. So as the light is focused here in our LDR, the number of LEDs that light up is now, okay, 0. And if I just move it away for a bit, okay, the LEDs turn on. Okay, and it reaches its normal value, which is, okay, let us check in the serial monitor. So it is currently lighting up 5 LEDs. Okay, it's actually less than 60 now. Okay, so let me cover this again and remove the cover. Okay, it's actually between 59 and 60. It is fluctuating. Okay, so as you can see here, our LDR does not have exact values for the uh, its resistance because it is light dependent. So this is our circuit applied to the universal PCB. So we have some changes here. Instead of using 10 LEDs, we have used 15 LEDs. However, since the Arduino does not have 15 digital outputs, we will be using only 8 outputs. So these are the positive ends of the LED. So for our outputs, 7 of the outputs will drive 2 LEDs. So a total of 14 LEDs. And the 8th output will only drive 1 LED for a total of 15 LEDs. And these 8 resistors here are connected to the pins here in the stackable header, so that they can be readily connected to our Arduino. And also here is our ground connection for the LEDs. Next is our sensor circuit. So we have here the LDR, and we also have here the load resistor of 5 kilo ohms. So the input, 5 volts input here, this line here, is connected also to the stackable header so that it can be readily connected to the Arduino. And here is our ground, so it is also connected to our 5K resistor here, and also connected to the stackable header. And we also have the analog input here, so it can be it is connected between the connection of the LDR and the 5K resistor.